Assalamualaikum and hi everyone. Today we are going to learn about lines and planes in subtopic 1.4. Okay, so if you refer to your module, you may turn to page 49. Okay, page 49. Alright. So basically, in this subtopic, we will learn about equations of lines and also equations of planes. Okay. So I already prepared some slides for you. Okay, so basically in this video, I will explain to you each subtopics in equations of lines and planes, but I will give you a different example. Okay, and all the examples actually are similar to the examples in our module, but I changed the values so that you can have more examples regarding to the subtopic. Okay, so let me explain about the equation of lines. Basically, in equations of lines, we will have three equations. Okay, we will have vector equations. So this is the formula of vector equations, and we also have parametric equations. Okay, so this is the formula of parametric equations, and then we will have symmetric equations of line. Okay. So now guys, let's say we have this line. Okay, the black color is the line, and then we will have a parallel vector v. Okay, this is the parallel vector v. We'll use the blue color. This is the parallel vector v that parallel to this line L. This is the line L, the black color. Okay, all right, if you look here, we have this direction and this is the direction for the line. Okay, so in equation of line, first we need to have the parallel vector v. Okay, number two, we need to have the P naught. Okay, we need to have a point P naught, which is located on the line. So in this case, all right, this is our P naught. This is the point of P naught. Okay, so if we have these two informations, then we can form the equations of the line. Okay, so as I mentioned earlier, we have vector equation of a line. So we have R equals to R naught plus TV. So now R naught is actually representing the point of P naught. Okay, so the element of P naught is X naught, Y naught, and Z naught. Sorry. And then we have the parallel vector V. Okay, this parallel vector V, the element is A, B, and C. Okay, so what you need to do is just plug in all the values of X naught, Y naught, Z naught, and ABC into this formula. Okay, and from the vector equation, we can find the parametric equations of the line. We have X equals to, okay, so I want you to follow me here. Look here, we have X naught, and A. Okay, I direction. This is the vector. So we will do it by component wise. Component for I, component for J, and component for K. So for the first component, okay, let me erase this first. We have X equals to X naught plus AT. So we get the first equation, parametric equation of the line. And then second, we have Y here, Y naught here, and B here. So the process is Y equals to Y naught plus BT. Okay. And then we have, let me use, let's say blue color. So we have Z equals to z naught plus t times c. So for kth component, we will have equation of z equals to z naught plus ct. Okay, so now, how do we get the symmetric equation? Actually, symmetric equations is derived from the parametric equation. Alright, if you notice here, if you notice in parametric equations, we have the same parameter t for each component, x, y, and z. So if we factor out t, okay, in this case, if we factor t, we will get t equals to x minus x naught over a for the x equation, and then for y equation, we also have t equals to y minus y naught over b, right? And then for z equation, we also have t equals to z minus z naught over c. Okay, so that's from this process, we can form the symmetric equation. Yes, so this is the symmetric equation. X equals x minus x naught over a is equivalent to y minus y naught over b and equals to z minus z naught over c. Okay, because all of these are equivalent to t. Alright, now let's take a look at example 1, and this example is similar to example 1.4.1.1 in our module. Okay, find the parametric equations of the line passing through the point 7,3 and parallel to y-axis. Okay, so now again, in order to form equation of line, we need two information. The first one is we need to have the parallel vector v, which is a, b, and c. This is the acute angle. Acute angle is acute symbol is for the vector. All right. And then we also need to have the p naught, a point. Which is x naught, y naught, and z naught. Okay. Since this equation is focused on 2 dimension. Okay, 2 dimension. So we just have x naught and y naught. Okay, so this is our x naught and y naught. Okay, so point P is 7 and 3. Alright. And then parallel to y-axis, it said that the line is parallel to y-axis. So as I mentioned earlier, we need to find the parallel vector, right? So in this case, V is parallel to y-axis. Okay, thus we can say that V is equivalent to J direction. Okay, actually you can also have V equals to 2J or 2J or negative 4J, as long as it is parallel to y-axis. Okay, so let's say I choose V equals to J. Alright, so we have V equals to, in sharp bracket, we have V equals to 0i plus 1j, so 0, 1. Alright, now, okay, now guys, we have x naught here and y naught here, and this is our A and B. Okay, so the question asks you to find the parametric equations. Alright, so parametric equation said that we have thus x equals to x naught plus AT, y equals to y naught plus BT. Okay, since this problem is 2D, so we just have x and y direction. Therefore, the answer is x naught. X naught is 7, so 7 plus AT. A is 0, so we just have 7. Okay, and then y equals to y naught. Y naught in this case is 3 plus b. B in this case is 1, so 1 times t should be t. Alright, so that's it. That's the answer. It's very simple. Okay. Okay, next. Find parametric equations and symmetric equations of the line L passing through the point P6, negative 1, 2 and parallel to the vector V equals to 2i plus 5j minus 3k. And then we need to find 2 more points that lies on the line. Alright, as usual, we need to take out the given information. We have P naught equals to 6, negative 1 and 2. And then V equals to, we have 2, 5, negative 3. So guys, in this case, this is our x naught, y naught, and z naught. And this is our A, B, and C. So just simply substitute all of these values into the formula. Then we get the parametric equations of line equals to x naught plus AT. So we have 6 plus 2t. Y equals to a negative 1 plus 5t. And then z equals to 2 minus 3t. Okay, so that's it. That's the answer for the parametric equations of lines. Okay, next we need to find the symmetric equations of line. Okay, so symmetric equations. As I explained in the first slide, symmetric equations is derived from the parametric equation, right? So we just find the function for t, the equation for t. So now we will have x minus 6 over 2 equals to y plus 1 over 5 equals to z minus 2 over negative 3. So that's it. That's the answer for symmetric equations of line. Okay, next. The question asks you to find 2 more points that lies on the line. So in order to find 2 more points on the line, what we should do is we need to substitute the values of t. Okay, so find 2 more points. 2 more points on the line L. We need to substitute the values of t. So let's say we substitute, let t equals to 1. So we need to substitute the values of t into the parametric equations. Okay, so we have x, 6 plus 2 times 1, so we have 8. Y equals to negative 1 plus 5 times 1 equals to 4. And then z equals to 2 minus 3 times 1, we have negative 1. So one of the point is 8, 4, negative 1. Alright, so another point. Actually, you can substitute any values of t except 0, because why? If we substitute t equals to 0 into the parametric equation, we will get back the p naught. Okay, so we don't want the same coordinate. We want the other points on the line. So we need to substitute the values of t, any values of t except 0. So let's say for the second point, I substitute t equals to 2. Okay, so we have x equals to 6 plus 2 times 2, we get 10. And then y equals to negative 1 plus 5 times 2 equals to 9. and then z equals to 2 minus 3 times 2, we will get negative 4. So the second point that lies on the line L is 10, 9, negative 4. So that's it. That's the answer. Okay, next example. Example 3. This example similar to 1.4.1.3. Okay, find parametric equations of the lines L1, L2, and L3 as shown in the following diagram. Okay, so we have 3 lines here. Alright, so let us find the equation for L1 first. Okay, so equation for L1. Okay, again, we need two informations, right? We need to have a point P naught and then a parallel vector, okay? So what you should do here is, okay, this is the line of L1. Let me highlight this. Here, this is the line of L1. So we have two coordinates on the line. Okay, two coordinates on the line. We have P naught. The first point here, P naught, is coordinate of 0, 8. Okay, if I can denote here, the coordinate here is 0, 8. Okay, and the coordinate here is 6, 8. Okay, so these two coordinates lies on the first line. So now we have P naught 0, 8 and P1. Okay, let's say the second coordinate is denoted as P1. We have 6, 8. Okay, so now what's the missing information here in order to find the parametric equation of line? We don't have the parallel vector, right? So now our task is we need to find the parallel vector first. Okay, so how do we find the parallel vector? Parallel vector V is actually the vector that passing from P0 to P1. Okay, so what we can do here is we need to deduct, okay, the coordinate of P1 or the vector of P1 minus P0, 0, 8. Okay, let me put here P1 minus P0. This is P1 minus P0. Okay, so we have the vector is 6, 0. So now we have already enough information to form the equation of line for L1. Okay, I rewrite this again. P0 is 0, 8, and then we have V equals to 6, 0. Okay, so this is our x0 and y0, and this is our A and B. Okay, therefore the parametric equation of line L1 is x equals to x0 plus 80, so 0 plus 60, so 60, and then y equals to 8 plus 0t, so 8. Okay, so that's it. That's the answer for parametric equations of L1. Done. Okay, next. Equation for L2. We have L2. Okay, so now this is the line for L2. Okay, right here we have a coordinate P naught as 60. Okay, 60 to 68. Alright, so now our P naught is 60 and P1 is 68. Okay, so again we need to find the parallel vector. So P1 vector from P0 to P1. So P1 minus P0, we have 6, 8 minus 6, 0. We will get 6 minus 6 is 0, and then we have 8. Okay, so in this case, let me add the page. Okay, paper. Alright, so now for the second line, L2, I rewrite the informations given. We have P0 as 60 and V as 0, 8. Okay, so this is our X0 and Y0 now, and this is our A and B. Therefore, we have this. Therefore, the parametric equations of L2 is parametric equation for L2 is X equals to X0 plus AT, so equals to 6, and then Y equals to Y0 plus BT, so Y0 is 0 and B is 8, so 8T. That's it. That's the answer. Okay. Next equation for L3. Okay, we have this is the line L3. Okay, so the coordinate involved here, this is the coordinate involved here is 0, 0. Okay, so we can say that to form equation for the third line, L3, we have P0 as 0, 0. And again, P1 is 6, 8. Okay, so yes, the same step. We need to find the V, P0 until P1. So P1 minus P0. So we have 6, 8 minus vector of 0, 0. So we have 6, 8. Yes, like this. So now, therefore, the equation for L3 should be, okay, in this case, this is our X0 and Y0, and this is our coordinate, parallel vector of A and B. So X equals to X0 plus AT. We have X equals to, X0 is 0, so we have 60. Y equals to Y0 plus BT. Y equals to 0 again, because Y0 here is 0, plus BT, so 8T. Alright, so this is the answer. That's it. Done. Okay, example 4. Find the parametric equations of the line that is tangent. Okay, tangent to parabola y equals to 3x squared. Okay, so now first we need to find the tangent. Okay, so tangent of y equals to 3x squared is we need to differentiate. Okay, so dy over dx equals to 6x. Okay, so given that at the point, this is the point 2, 12. So at point 2, 12, we have point 2, 12 dy dx equals to 6 times x. X is 2, so 2. So equals to 12. Okay, next. We can find the parallel vector. Okay, since dy dx equals to 12. Okay guys, what we should do here is this is actually j direction. This is over 1, right? So this is I direction. Okay, thus the parallel vector v is I equals to 1. So because dx is for I direction, so we have 1I plus 12j. Alright, so we already have enough information to form the equation of the line. So in this question we have point P naught to 12 and the parallel vector equals to 1, 12. Okay, this is 1, 12. So now we already have enough information. This is our x naught, y naught, and this is a and b. So we can form the the parametric equations of the line. Okay, therefore x equals to x naught plus at is x equals to x naught is 2 plus 1, so plus 1t. Y equals to y naught plus bt, so y equals to y naught is 12 plus 12t. So that's it, that's the answer. Okay, so if I sketch the graph of y equals to 3x squared, you will get something looks like this. Say this is the parabola. Okay, so let me denote the coordinate of 2, 12. Okay, let's say this is point 2 and this is point 12. Okay, this is coordinate x and y. So we have this coordinate 2, 12. Right, so now the tangent vector is 1, 12. So tangent vector 1, 12. Let me use the purple color. So 1, the parallel vector is the tangent vector. So we move to the right 1 step and then we go up 12 steps. So this is the tangent vector. V equals to 112. Okay, this is how it looks like. So that's all for example 4. Next, example 5. Find the parametric equations of the line L passing through, okay, right now, passing through the points P and Q. Okay, so we have two coordinates here. Okay, we have P 2, 1, negative 3, and Q equals to 5, negative 1, negative 2. Okay, so in order to form the equation of line, we need to have two informations, right? We need to have point and we need to have parallel vector. In this case, we don't have the parallel vector, so we need to find the parallel vector. Okay, the same step as example 3. Okay, how do we find the parallel vector? Is by find the vector from the P to P0 to P1. So in this case, we need to find the vector from P to Q. Okay, so we will have vector for Q minus vector for P. So we have 5, negative 1, negative 2 minus 2, 1, negative 3. So therefore, 5 minus 2 is 3. And then negative 1 minus 1, we get negative 2. And then negative 2 minus 3, we get 1. Okay. So this is our V. So this is our A, B, and C. Okay. Let's just consider P0 as 2, 1, negative 3. So therefore, this is our X0, Y0, and Z0. Okay, now. Therefore, the equation of the line is X equals to X0 plus AT, Y equals to Y0 plus BT, Z equals to Z0 plus CT. So we will have X equals to X0 2 plus 3T, Y equals to Y0 1 plus negative 2T, and Z equals to negative 3 plus 1T. So plus T, like this. Okay. Next, the question asks to find the point of intersection between the line L and XZ plane. Okay, line L and Z plane. Point of intersection. Oops, sorry. Intersection between the line and XZ plane. Okay, when we said that XZ plane means the coordinate of y equals to 0. Okay, if the question asks you to find the intersection point between the line and XY plane, if XY plane means z equals to 0. Okay, and if the question asks YZ plane, so the coordinate x will be 0. Okay, let me denote here. If YZ plane x equals to 0, if xz plane y equals to 0, and then if xy plane should be z equals to 0. Okay, this is the short notes. So in this case, xz plane, therefore y equals to 0. Okay, so what we should to do next is, since y equals to 0, thus from the equation of line, y equals to 1 minus 2 times 0. Alright. Sorry. Y minus 2t. Okay. So equate this with 0. 1 minus 2t equals to 0. So 2t equals to 1. Therefore t equals to 1 over 2. Right. Okay, I have to add some page. Okay. So now t equals to half. We need to find the coordinate of for x and z, right? So substitute t equals to half in x. Thus x equals to 2 plus 3 times half. We will get 2 plus 3 over 2 should be equals to 7 over 2. And then z equals to negative 3 plus half. We have negative 3 plus half. We get negative 5 over 2. Over 2. Okay. So that's it. So now therefore, the point of intersection, is, we have 7 over 2, and then y equals to 0, and then z equals to negative 5 over 2. Okay, that's it. This is the final answer. Okay, next, characteristic of lines. Okay, if we have more than one line, okay, let's say we have line L1 and L2. L1 and L2 can be parallel if we have this formation. Okay, and how do we test whether the two lines are parallel? We have the formula of V1 equals to KV2. And then we also can have intersecting lines. Okay, L1 and L2 can be intersect if we have this kind of formation. So what we should do in order to determine the intersection point between L1 and L2 is we need to find all the values of T and S that fulfill all the equations of the lines. Okay, I will show you the steps later. Okay, and this is how skew lines looks like. Okay, they are skew lines means they are not parallel and not intersect. Okay, so let's take a look at example 6. Example 6, we have line L1 and L2. First, are the lines parallel? Okay, so we need to find okay, let us solve question A first. So V1 is negative 3, 7 and 2, and then the parallel vector for the second line is 5, 2 and 1. Okay, if you notice here, there are no factors such that V1 equivalent to KV2, right? So to test parallel, we need to find the values of K. K is a constant, okay? Any constant that fulfills this equation. K can be any numbers. K can be positive, K can be negative. But there are no coefficient of k here such that V1 equivalent to V2. Okay, so negative 3 times what to get 5? No, we don't have any values, that right? 7 cannot be multiplied by any number, we cannot get 2 from 7. All right, so there is no k here. Therefore, since V1 not equivalent to k V2, thus L1 and L2 are not parallel. Okay, question B. Does the lines intersect? Okay, now what we should do here is we need to form equations for x, y, and z. Okay, so we have x does intersect. We have equation for x equivalence to 2 minus 3t equate this with 5s. Okay, and then y is, we have 1 plus 7t equals to 1 plus 2s. And then for z, we have 4 plus 2t equate to negative 3 plus s. Alright, so we have 3 equations here. Equation 1, equation 2, and this is equation 3. Okay, as I mentioned earlier in this slide, in order to determine whether the lines are intersect, we need to find the values of t and s that fulfill all the equations of the lines. Okay, so now we need to find the values of t and s that fulfill all of the 3 equations. So we need to solve simultaneous equations here. Let us solve equation 2 and 3 first. We need to solve simultaneous equation. Okay, let us solve equation 2 and 3 first. So what we should do is, from equation, we need to equate. Let's say I want to equate the variable s here in equation 3. So I have to multiply, okay, from equation 3, I need to multiply this with 2. So 4 times 2, we get 8, plus 2 times 2 is 40, equals to negative 3 times 2 is negative 6, plus 2s. Okay, therefore this becomes the 4th equation. So now equation 2 can minus equation 4. So 1 minus 8 should be negative 7. 70 minus 40, we get 3t equals to 1 minus 6, we get 7. And then 2s minus 2s, we get 0. Okay, so we can solve this 3t. 7 plus 7 is 14, therefore t equals to 14 over 3. Okay. So now we already get the values of t. Next we need to find the values of s. So how do we find values of s? Substitute t equals to 14 over 3 into equation 2. From equation 2, we have 1 plus 70, so 1 plus 7 times t is 14 over 3 equals to 1 plus 2s. So 1 plus 2s. Let us solve this. We have 1 plus 7 times 14 should be 98 over 3 equals to 1 plus 2s. So we can cancel this and this. So 98 over 6. We have 98 over 3 equals to 2s. So we have s, therefore s equals to 98 over 6, or we can say that this is 49 over 3. Okay, so we already have the values of t, 14 over 3, and s equals to 49 over 3. Now what we should do here is we need to test whether t equals to 14 over 3 and s equals to 49 over 3 fulfill the equation 1. Okay, why we test in equation 1? Because previously we solve equation 2 and 3. Okay, we solve equation 2 and 3. So that's why in this step we need to test whether this value fulfill the first equation. Okay, because we know that these values fulfill equation 2 and equation 3. So we need to test now whether this value also fulfill the first equation. So substitute, guys, into the first equation. We have 2 minus 3 times 14 over 3. Is it equals to 5s? So 5 times 49 over 3. Okay. So here we have 2 minus 14. We get negative 12. Is it equals to the 5 times 49? Should be 245 over 3. This is not equals, right? So since this is not equal, means that the values are not fulfill equation 1, not fulfill. Okay, not fulfill. Not fulfill equation 1. Therefore, the lines not intersect. Not intersect. Since both lines are not parallel and not intersect, there are skew. The lines are skew. That's it.